Here we are again at REM 456. Today we're going to talk about toxic range plants in this integrated rangeland management class, whereas these three critters are asking us to eat or not to eat. Anti-quality or toxic agents in plants can be divided into three general categories. The first is a set of compounds in plants that simply resist digestion. This could be things like lignin, silica, or tannins, which they themselves are just not digestible. So if you get more of that in a plant, it makes the plant less digestible. These are the most common defenses in grasses, and basically what these compounds do is they simply reduce the digestive feedback. So they reduce the palatability of the plant. They don't necessarily make the animal sick, but they just make it less desirable. Second set of compounds inhibit digestion. So they do things like kill microbes in the rumen so that the rumen is not as active and able to digest the diet. A good example is essential oils in either sagebrush or pine. One of the characteristics of those compounds is that they kill microbes, and since the rumen is full of microbes, if you have a lot of these compounds in the rumen, they can really reduce the efficiency of digestion. Others are things like tannins that bind with nutrients and make them indigestible. So tannins actually bind with proteins, and they make the proteins indigestible. So that's a second category of compounds, those that inhibit digestion. The last set of compounds would be those that we actually call toxic, that have detrimental effects on animals.
For me, when I talk about toxic or poisonous plant compounds, I'm talking about plant compounds that cause negative digestive or physiological effects. So they do more than just reduce digestibility. They actually have negative effects on the animal. Those negative effects range widely. They can be death. They could have effects like birth defects. Crooked calf disease is a compound that causes young calves or lambs to have frozen joints. That's a teratogenic effect. So things that are birth defects are teratogenic effects. It could be reproductive dysfunction, it could be bloat, it could be compounds that affect the skin in dermatitis or sores, neurological effects such as animals that tend to go crazy or are shaking. All of those are symptoms of toxic plants, and the variety of things that can happen to animals when they eat toxic plants is wide. We'll go through some. How animals learn to avoid plants is based on consequences. The kind of consequence it varies among plants. The consequence might affect the skin defense system or the gut defense system. Plants that cause pain when they're touched or eaten affect the skin defense system, and it's pretty simple, the same way that you learn to avoid hot stoves or irons. As you touched it once, it caused pain and you step back. So kids usually learn to avoid things that cause pain. So do cows and sheep and deer and goats and rabbits. They eat a plant that causes pain, they tend not to go back to it. The other kind of system that teaches animals to avoid toxic plants is the gut defense system. An animal eats something, it becomes nauseous, tends to avoid that plant in the future. For each of these. Again, with the skin defense system, it relies on pain. So animal touches the plant and gets like thorns or spines, touch the nose or the lips or the tongue, and that causes pain, so the animal will tend to avoid it. There's other compounds that do cause irritation to the skin, but it can be quite delayed, such as poison ivy. The animal rubs up against it and it will become inflamed minutes or hours later. It's hard for animals to learn to avoid things that cause pain if the touching it happened hours before the pain. So that time delay between the touching and the pain is important. The more closely those are, the more easy it is for animals to learn to avoid those plants. The gut defense system is quite different. An animal eats a plant, tastes a plant, and hours later it will have some digestive feedback, minutes or hours later. If that digestive feedback is positive, like they get an energy boost or it satisfies a craving for nitrogen or for protein, they'll tend to form a preference for that food. On the other hand, if they eat something and they get digestive feedback, specifically nausea, if they feel nauseous, they'll form an aversion. Probably quite a few of you have aversions. You ate something one time and it made you sick, and you become averted to it. You don't ever want to see the thing again. Animals have these same kind of aversions. Generally, in ruminants and grazing animals, we don't see lifelong aversions, but we can certainly reduce palatability of foods based on negative feedback. Another kind of detail of this gut defense system is that when an animal eats a food, depending on the feedback, that determines the level of preference or aversion. So foods that have really high energy, really good, strong, effective, positive feedback, animals will form really strong preferences for them. So, for humans it might be something like chocolate or, high energy potato chips, things that have fat in them. We have strong preferences for them. Foods that are really neither great or bad, like for us, celery, it's hard to form a strong preference for celery unless, of course, it has cheese in it. And the same is true with compounds out in nature. If it doesn't have a really strong benefit or strong detriment, animals will maybe be fairly neutral to it. On the other hand, if an animal eats a food, becomes violently ill, and again, nauseous, they can form very strong aversions to foods. Here's how that happens in nature. An animal encounters a new plant, sees it and smells it. It's really important that the taste and eating of the food, the consequences are related to the taste of food. If the animal gets negative feedback, feels nauseous, the taste becomes distasteful. The flavor of the plant becomes distasteful. When the animal encounters that plant in the future, they'll avoid it. They don't eat it. And so that's what we call the aversion. When we see animals avoiding foods, we call that an aversion. It's important that grazing animals, foraging animals, try things in nature. So usually they don't avoid foods for a life. They usually get started back on them because their peers are eating them. So behavior of peers influences whether they start eating food or not. The previous experience with the plant, if they've been eating alfalfa all their life and one day they got sick, they tend not to blame the alfalfa because it's a familiar food. On the other hand, if they've been eating some nightshade or something and they'd gotten sick a little bit every time they ate it and then ate it again and got really sick, then they would tend to blame the nightshade. So the previous experience is important. And then finally, just remember that there's a lot of toxic compounds out in nature. If animals avoided every toxin food, there would be nothing left to eat. So they are always sampling food and always trying to see if it's good or bad food. Always we're looking at taste and relating it to feedback. If feedback is negative, the taste becomes unpalatable or distasteful. Okay, I'm going to talk a lot about the effect of these toxins on mammalian herbivores, mostly ruminants and grazing animals, but just remember that plants probably didn't make the toxins specifically for mammalian herbivores. Yes, they may have an effect, but the toxins may have been created for other reasons. They might have been created to avoid microbes, fungus or bacteria on the plant. The plant might be creating these compounds to resist herbivores, such as mammals, but probably more importantly insects. Insects remove more biomass on range than mammals, so plants have a lot of benefit to produce compounds that reduce insect herbivory. They also might have been created to ward off neighboring plants. Anti-plant compounds are called allelopathic compounds, allelopathy. In the video by Barton from the University of Wyoming, he talks about knapweed, which has a known chemical that when it comes out, it exudes it from the roots, and it stops other plants from invading into that space and taking nutrients out and water out of the soil. So that's an anti-plant compound. Finally, many compounds in plants are just designed to help the plant deal with environmental extremes, to absorb or reflect excessive UV radiation, to help the plant survive moisture stress or low temperatures and or high temperatures. So plant compounds could be useful just to mediate environmental extremes. I will often use this word secondary compound. I just wanted to let you know where that comes from. In the kind of lexicon of botany, primary metabolism are systems and compounds that create growth and reproduction. So anytime a plant has a metabolic system or a metabolic pathway that leads to a compound that isn't necessarily used for growth or reproduction, that system is called a secondary metabolism pathway. So there's a lot of compounds that go through these secondary metabolism pathways, and often those are toxic. So they are kind of secondary importance to the plants. They're not primary, they don't contribute to growth and reproduction. Keep in mind, though, that some of the metabolites that come out of primary metabolism, such as nitrates, they are used in growth and reproduction, but they can also be toxic to the animal. If too many nitrates are eaten, it can cause death and loss of activity in the animal. So we'll talk about nitrates as an example. Okay, that all sounds really simple. The plant has a compound, it affects the animal, but how toxic a compound is really complex. There's a whole set of plant attributes that influence how toxic a compound is to an animal. For example, the phenological stage. A plant can have a secondary compound that is toxic when the plant is young, but not when the plant is flowering, or vice versa. The plant cannot be toxic when it's growing until it flowers and produces seeds. So one of the problems with learning about when plants are toxic is trying to really keep track of what phenological stage is the plant most toxic. Some plants will be toxic at one ecological site but not at another. That usually depends on what soil nutrients are available. Plants can tend to accumulate certain nutrients that would make them toxic. So, place to place, time to time. Weather can also affect whether a plant is toxic. Some plants will spend most of their life being not toxic, and then some strange combination of early spring weather and a freeze, for example, will make a situation where the plant becomes toxic overnight. Environmental stresses, we find plants that are toxic during drought, but not other times of the year. Also, if there's a wet spring, sometimes we'll have toxins that accumulate, whereas if it's a dry spring, they won't. So the environmental stress can influence whether toxins are created in the plant or not. And then finally, plant part. Throughout any plant, it can tend to accumulate toxins at different parts of the plant. Some plants will be toxic in their leaves, others will be the stems. Many times the toxins are concentrated in the flowers or the fruits. So you have to know the plant part, where it's growing, what time of year, what kind of conditions it's in. It's complicated. Animal attributes also influence the toxicity of plants. The poison is in the dose. So many toxins can be eaten in small dose, and it can even have some benefits to the animal, some medicinal kind of benefits, but when they're eaten in high doses, they can be deadly. Even salt. For example, animals need salt. We all need salt. Mammals need salt. But too much salt can cause death. It can be really bad. The species is important. Species vary by the kinds of microbes they have, their level of liver activity, the kind of cellular enzymes they have. All of those attributes that make up the species of the animal can influence whether a toxin is deadly or not to an animal. So for example, we have sheep that might be more tolerant of a toxin than cattle. Oftentimes one example of that is tall larkspur, which is a terrible toxic plant to cattle, is not very toxic to sheep. So historically, sheep bands would go through an area with a lot of tall larkspur, and the sheep would eat it without any negative effects. It's actually quite nutritious and delicious to them. So they eat it and remove it, and what's left is the grass that the cows come through later to eat. So that's an importance of animal species. Another one, especially because horses are not ruminants, there will be compounds that will be deadly to horses but not affect cattle or sheep or goats. What other plants are in the diet can also influence how toxic a plant is. Animals can learn to eat combinations of plants. The compounds from one plant can cancel out the compounds in another, so animals can learn to sort of take antidotes to the toxins that are in their environment. And unfortunately, sometimes by accident, they can take two plants that accentuate the toxicity of each other too. Hormonal state can be important. There are a few plants that are toxic when an animal is, for example, pregnant, but not toxic when an animal is dry. So the hormonal state of the animal can be important. And now we also know that the body condition is highly important. Fat animals are usually not as they're usually more tolerant to toxins than thin animals. So all of those factors can make a plant toxic and cause variation, and that's why the whole area of toxic plants is a challenging and dynamic area. So now let's go into what some of those toxic plants are, those secondary compounds or anti-quality compounds. Here's the list that we're going to go through. We're going to go through a few that are called quality compounds because qualitative defenses because they are effective in small quantities, alkaloids, glycosides, nitrates, soluble oxalates. A couple that usually are called quantitative defenses because they take quite a large number to be effective, quite a large amount in the plant to be effective. Tannins, essential oils, and then I'm going to throw in a couple examples of photosensitization and dermatitis, so plants that affect that skin defense system. Let's start with alkaloids. Alkaloids, a good reason to start there is because they're the most powerful among the groups of chemicals. Think about this list: caffeine, morphine, codeine, heroin, cocaine. They're all effective compounds, God knows it. And they are effective in all mammals and ruminants and non-ruminants. So these compounds can be effective in very small amounts, and that's another reason that they're rather dangerous and powerful toxic chemicals. Other reasons that they're effective: one, they're as I said, they're effective in small amounts, doesn't take much. They also tend to be stable, whether the plant freezes or is dried in hay or is boiled. These compounds tend to be fairly stable. They cause nervous disorders. They cause, just like, think about caffeine, it causes your heart to race, gives you kind of a buzz, but it doesn't necessarily make you sick. In fact, the compounds in coffee that make you sick are not the caffeine, they're usually tannins and other compounds. So one of the problems with these alkaloids is they don't affect the gut defense system. They affect the skin defense system. It's really hard for an animal to eat a food, a few hours later feel fidgety or have some nervous disorder and relate that to a food. So one of the real problems is it doesn't make the animal sick. Alkaloids tend not to make animals sick, and they therefore are very difficult for animals to learn to avoid. Some examples of plants that have alkaloids in them: lupins, loco weeds. We talk about people being loco or being crazy, so crazy weeds, again, those are parts of the skin defense system. They affect the nervous system. Larkspur, especially tall larkspur. Tall larkspur is the plant that causes the most deaths of livestock in western North America. Very effective plant. Low larkspur is also a cousin to tall larkspur, and it is even more toxic. It just doesn't tend to get eaten as much, so it's not as deadly. Bitterweed, a problem. Water hemlock is a problem for grazing animals, but also humans. This is the one that killed Socrates. The alkaloids in the root are really, really effective in really small amounts. And another problem with them is hikers and stuff will find this plant. It looks a little bit like wild parsley or bitterroot or biscuit root plants. So they'll pull up the root. It is a fleshy root. They boil it thinking they're going to kill anything that's in it, and in fact those alkaloids are still quite stable, and they eat it and they die quite quickly. It's a very effective toxin. So water hemlock is deadly to livestock, but also humans. Let's talk a little bit about glycosides next. Glycosides work in the plant, and they create sort of a cyanide-like compound, and so quite deadly. Cyanide is deadly, so are glycosides. They are naturally occurring in plants, many plants. The effect that they have on plants is the effect they have on animals is that they block oxygen transport, so animals essentially suffocate. They're pretty toxic if eaten in sufficient quantities, and they work on a large range of animals. And then again, the problem with them, like alkaloids, is they don't make the animals sick, so they don't provide that negative digestive feedback. The effect of blocking oxygen is just something that's hard for animals to learn to avoid a food because they couldn't breathe. So another problem with glycosides is they're highly variable in time and space. This is a group of chemicals that can really be in a plant but not converted to a toxic compound until a freeze or till a drought or till some hot day and cold night. So the environmental conditions can really change it from being pretty benign to very toxic overnight. Glycosides, plants that have glycosides: Johnson grass, chokecherry is one that we see occasionally a rash of poisonings from, and then most of the time it's just fine. Mountain mahogany, burr buttercup, white clover, serviceberry, all of those plants generally are not considered toxic, and then some strange combination will make them convert these glycosides into toxic compounds and become, highly toxic. Nitrates, another one. I mentioned that these are primary metabolites. They're part of growth and reproduction in the plant, but they can accumulate in the plant under certain conditions. High nitrogen, like after fertilizing an area, or on range sites that have particularly high nitrogen. In droughts, we can see an accumulation of nitrates. Low light conditions. When there's not enough light, the plant is not photosynthesizing effectively, so it's not producing carbon-based compounds. Like, it's not producing enough of the structural carbohydrates, and therefore the nitrates tend to accumulate. Also herbicides. You'll hear people will talk about having problems with poisoning after an herbicide is applied. Sometimes it's not the herbicide that's the problem. The problem is that it creates a nitrogen accumulation in the plant. 2,4-D is the one that we know this from. So when you spray 2,4-D, it's important to follow the label and wait to put animals in the pasture until after that herbicide has had its effect. What nitrates do is similar to other compounds. It blocks the ability of the blood to carry nitrogen, and it doesn't cause illness. So it doesn't usually lead to an aversion. So it's difficult for animals to detect and avoid. Some compounds that can accumulate nitrate, these are mostly from the chenopode family, the goosefoot family. Careless weed, Russian thistle, kochia, and then silver nightshade, which is also can be quite a problem in this effect of accumulated nitrogen. Oxalates, another set of compounds that we would call qualitative because they're effective in fairly small amounts. And again, this is a compound that, like the previous ones, affects the nervous system. And that's a difficult thing for animals to learn to avoid because it affects the nervous system and doesn't make them sick. Also, oxalates are also interesting because sheep tend to be more susceptible to oxalates than cattle. So they tend to be more toxic to sheep than cattle. And an example of that is halogen. There were some real horror stories at the turn of the last century where groups of sheep in southern Idaho were brought down from the mountains and ate too much oxalates from halogen. So they just they just got onto a flat that had a lot of halogen. They ate too much of it, and hundreds of sheep can die from a band if they overeat this halogen that has oxalates in it. Greasewood is one that we don't usually think of as a toxic plant. Animals don't like it very much, but it does. It is one that will accumulate oxalates. Okay, now let's go on to those other ones that we would say are effective really in large amounts, and tannins would be the first of those. Tannins, their main effect they have on the forage is they reduce protein digestion. They actually grab the protein and make it indigestible. They don't usually cause nausea except at really high levels, and animals can learn to avoid it because at high levels it does make them sick. But the effect that we usually see on animals with animals is decreased weight gain because of the low protein availability. Tannins are very seldom lethal, but there is a disease called oak poisoning that happens on Chinnery oak in Oklahoma and a little bit in Texas, and sometimes you'll see it on Gamble's oak in the Colorado bench lands. But usually we don't think of tannins as being lethal, but they can in some cases. Plants that contain tannins then would be oak brushes. I mentioned those. Most oaks have tannins. Black brush is called black brush because it's gray and turns black, and that black characteristic is from the tannins. Mule's ear is another plant. We have it throughout the West. It's not terribly toxic, but animals don't like it. And the reason they don't like it is probably because of those tannins. It doesn't give them very much positive feedback. And if you try to press the leaves of mule's ear, it turns black, really dark within just a few days. So that's another sign that it's got tannins in it. Another group of compounds which can be effective at high amounts are essential oils or terpenes. They are essential. When I used to teach this class, I one time was talking about essential. Why are these things essential? They're not essential for anyone. And someone in the class pointed out they're not essential, they're essential. They have an essence, they smell, they have a distinctive odor. So these are essential oils. The effect that they have is that they kill rumen microbes. Again, this is that pine sol effect I talked about earlier. So if an animal eats too much of this, they do get ill, they do feel nauseous, and it kills rumen microbes. So most often if animals are eating a lot of plants with terpenes, we see loss of weight gain. Very seldom would animals eat too many terpenes that they would die, so they're lethal only in really high quantities, and usually animals don't eat that much. Plants that contain essential oils: sagebrush, juniper, pine. Again, think about all those plants having, real essence to them, an odor. Also, these plants are quite flammable. They can, when fire comes along, they actually sort of explode. They are oils. So I've heard that people talk about when fire goes along and hits a juniper tree, for example, that it seems like it just explodes, and that's because of the essential oils. Another set of compounds will have specific effects. A wide variety of compounds will affect the animal in what we call photosensitization. It essentially makes them susceptible to sunburn. What we see in the animal is often a swelling or sloughing of the skin, and then a swelling of the head and ears. So the disease in sheep called big head is a type of photosensitization. What the compound actually does, it doesn't actually affect the skin, it affects the liver, and it reduces the ability of the liver to break down certain pigments, so then the animal becomes susceptible to sunburn. It can cause death in extreme cases, and it does not cause illness, so it's hard for animals to avoid. So again, think about it. It's hard for an animal to eat a food and then a few days later get a sunburn, essentially, and the swelling of the skin, and try to make the connection between a food eaten and this swelling of the skin. So it doesn't lead to conditioned food aversions, and it's difficult for animals to avoid. Plants that cause photosensitization include St. John's wort and horsebrush. Thinking about horsebrushes has an important role, because horsebrush is one of those plants that we see after a fire. So fire goes through one year, the next year the sagebrush is killed, and it won't come back until new seeds are put into the environment. But horsebrush resprouts from the root. It has buds at the root crown, and so it will resprout. So the first shrubs seen after fire are often rabbit brush and horsebrush. So animals will go through the environment and nip on a few horsebrushes, and then often that can lead to photosensitization or big head in sheep. Dermatitis is just a swelling of the skin. When we humans get it, we get all those red pocks and red swelling of the skin. It's harder to tell in livestock or wildlife, but it does occur. These are when the actual contact of the toxin on the skin causes irritation. So it's, again, something that affects the skin defense system. It's hard for animals to learn to avoid because it does not affect the gut defense system. It's rarely lethal, but it can sure cause production losses and discomfort in animals. Plants that you guys all know, probably poison ivy, poison sumac, poison oak. Remember, it's something that's hard to learn to avoid, so at least humans, we have all these little mnemonic devices like this poison ivy that's pictured here. Leaves of 3, leave it be. That's to remind us that we're not supposed to touch this stuff because it's hard to learn to avoid. So those are all the kinds. That's just a subset of the kinds of toxins that can affect plants. I'll list some more references on the website of good places to go if you think you have a poisonous plant issue. Some of the things that you can do to prevent poisonous outbreaks in grazing animals. One is to make sure to provide good forage. When animals are eating a good diet, they tend not to take in those poisonous plants. Some are exceptions, like tall larkspur, but a lot of poisons are avoided just by having good forage supply. Always provide good salt and minerals. Of course, that's important to production because it's important in metabolism of the animal. But also, when animals don't have salt and minerals, they tend to have cravings, and so they might be looking at using odd plants in the environment, often toxic plants, to satisfy those cravings. Try not to put hungry animals into pastures that have abundant toxic plants. Be careful when introducing animals to pastures with toxic plants. And so especially when animals are unfamiliar with pasture or a plant, you can have trouble. So just be careful in those situations. And when I say be careful in those situations, that means that you understand and are aware of what plants are in your environment and how they could affect the animal. So it takes a lot of manager knowledge. Sometimes plants can become such a problem that you need to consider removing animals from those pastures when toxic plants are available, and also consider removing them when you do some treatments like fertilizer or herbicide. Again, we mentioned the effect that 2,4-D can have on accumulating nitrates. Grazing pastures in season when plants are least toxic. There's a reading that you have in this class about how to avoid toxicity of tall larkspur, and that has a lot to do with just paying attention to the season of year. Try not to introduce toxic plants to the environment, and when possible, control them. Now that's not possible on most public lands. The Forest Service and BLM doesn't like spraying plants that are native, so unless something is noxious and on the noxious weed list, usually we don't spend resources to spray it. But on private lands, on someone's own private ranch, they often will spray weeds just to, they'll spray toxic plants to reduce any incident of poisoning in their animals. And then the example of trying to use the correct species is really important. Of course, it's hard to change the whole species of livestock that you have, but there are often cases where you can combine species to reduce toxicity. I gave the example earlier of sheep going through a pasture and grazing the tall larkspur. It's preferred food for them, and then leaving the grass for the cattle that will come through later. Several examples of where you combine animal species to be effective. So those are the major kind of topics of how toxic range plants affect animals and some of the main players that we have out on the range. And we will start to go into how metabolism is affected by plants in the future.